Okay, we stopped at imputing missing values. Okay, so before we start the next topic, okay, go ahead and run these 3 chunks of code. Okay, so you will have the data. First thing is to read the data file. Okay. All right. And then, okay, that's the first. The second chunk is to recode fireplace into a factor. Okay, and we did all this last time, so we need to bring the data back up to where we were. So the second chunk that you have to run is that one. And then we have to change the name of the first column from total dot value to total underscore value, because the rest of the code we are using underscore, so that's the reason. So these 3 chunks must be, so you must run these 3 chunks of code. Okay, so we don't need that. We need only the rename. That's probably the reason why it didn't run.
Yeah, mine is giving the same error.
Okay, so you need only the rename the first column. You don't need the rest. Okay. All right. So make sure that your housing df has a total value with an underscore between total and value, and then you do an str of housing .df and make sure that the fireplace and remodel are factor. So today we start with normalizing and rescaling data. Okay. And this is important when some data analytics model require computing what is called Euclidean distance between observations. Okay. And when we compute such distances between observations, okay, I know it's distance between observation doesn't make a whole lot of sense, but there is a way to doing that, and we will cover that when we get to those chapters. Okay, so in such a case, the magnitude of the variable can have an undue influence on the distance. So we want to bring all the variables into the same level playing field. That's what normalization does. And there are a couple of ways in which you can normalize. One is, of course, the regular z-score normalization, which we already did last time. So, normalizing, so brings all in the same scale. Z-score normalization is you use scales, right? We did that last time, so we do the same thing. So we computed z-scores when we use z-scores to see whether there are any outliers. So we can do the same thing here, and you can capture it in vectors and then replace the old variables with the normalized variables, right? So if you do scale is the code. Then, of course, you cannot scale a non-numeric variable. So you need to make sure that you remove the non-numeric variables. And here we have 2 non-numeric variables, the 2 factors, right? So those are like 13 and 14. Okay. Okay. C minus C 13 and 14 will remove those 2, and actually, we'll talk about that a little later. So I'm not going to save this, okay, because we don't need it for further analysis later on. But if you are actually doing this in a context of an analytical method, then you will save it in place of the old values. Okay, so you will have the normalized values. Okay, so I'm just going to show you how this is done. Okay, so now we have the normalized values. Okay. Of course, when you do this, when you're not capturing, if you're capturing, then it's not going to produce all those long output. If you're not capturing, then you say it's a results to height. So that is z-score normalizing. Because the last two variables are factors, that and that. So normalize, you normalize only numerical variables because you're computing z-score like x minus the mean divided by standard deviation, and that is possible only for numeric variables. You can't do that for character variables or factor variables. So that's the reason why you have to remove those two. Okay.